Now that we have looked at analysis on individual proportions, we can go ahead and do the two population analysis on the difference of the two proportions. Keep in mind that we do not know what the parameters are, so we cannot find the exact difference between the two proportions, but we can use the difference between the two sample proportions as a good estimate for the difference of the uh, population proportions. That would be the parameter. I am going to call this p hat no and call this p hat yes, and I'll take 0.476 or 0.475 and from that subtract 0.397. It would give me a positive value. You could take 0.397 minus 0.475, you get a negative value, but the positive is just better to look at. So let's just go here and label this cell as observed P no minus P yes. Implement the difference in this cell or wherever you like. You can just type in the expression for difference. That's equal, I'll take 0.475 minus 0.397 and press enter. The observed difference between the two proportions is 7.73%. That's a number that you get from the sample observation. To estimate an interval for the difference of the two proportions, you're going to need to find the standard error first. Let's call this cell standard error. And this is the standard error for the difference of the two proportions. And if you recall, that standard error is square root of p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. Implement that expression by typing in equal, again, the square root expression in Excel has a syntax sqrt, open parenthesis. P hat 1 we decided is 0.475. Just click on that, times 1 minus in parenthesis. That p hat is again 0.475. Just click on the cell that contains it, divided by n1. In this case, n here is 510 plus p hat 2 or p hat yes 0.397. Click on the cell, times 1 minus, click on the same cell, divided by the sample size here is 2,943. You could just click on the cell that contains 2,943, close parenthesis, and hit enter. And you can see the standard error for the difference of the two proportions is about 2.39%. To find the confidence interval, you need to compute the margin of error for, let's say, a 95% interval. We can type ME for say a 95%, ME for difference of the two proportions that is equal to, again, z alpha over 2 is 1.96 for a 95% confidence interval. Let me zoom in, times, let me do that again, equal to 1.96 times the standard error, which is sitting in this cell. Just click on the cell and then hit enter. The margin of error for the difference of the two proportions is about 4.68%. Now you can take the observed difference and do plus or minus the margin of error to find that 95% confidence interval. Let's do that in this cell. We do equal, take the observed difference of 7.73% by just clicking on the cell that contains it, minus the margin of error. That gives you the lower bound, and in the cell next to it you can do the observed difference plus the margin of error. Okay. Let's fill these cells with some color to indicate that we have main results. Just select those cells and choose any color of your choice. A 95% confidence interval for the difference of the two proportions is from 3.05% to 12%. You can see that this interval does not contain 0. That this conclusion can be used to reject the original hypothesis that the two proportions are equal. If they were equal, then the difference between the two values would be equal to 0, and the confidence interval would contain 0, but it just doesn't. And you can see some consistency between what we got here and what we have from the previous part when the two intervals did not overlap.